I'm Tyler Akidau, CTO here at Redpanda, and I'm now going to talk to you about the path to the agentic data plane. There's going to be a few different sections in this talk. To start out with, I'm going to give you kind of insight into the way we've been looking at what goes into the agentic data plane and why we, Redpanda, are a good fit for helping build this out. After I do that, I'm also going to explain kind of what beyond the things that we do here at Redpanda are necessary for the agentic data plane and some of the new additions we've added here at Redpanda to help enable that going forward. Then I'm going to spend a little bit of time talking about our roadmap, where we're headed, and when you can expect to see things delivered. And then after that, make sure you stick around, because we're going to have a demo of kind of all the key pieces of the agentic data plane from Johannes. So with that, I'm going to go ahead and get started. So to begin with, I like to give a little bit of context around the opportunity that we see here with AI. So AI has already materially changed the way that we live. AI agents are also going to then materially change the way that businesses are run. And we believe strongly that every business interaction will likely be mediated by AI in the near future. It's not a question of if, it's a matter of when, how, and who. If you look at the AI market today, the consumer market is flooded and largely successful, but the enterprise agentic AI market is foundering. Agents are super easy to build now, like you can build one in an afternoon, but running them safely in your private networks on private data is still hard. And why is that? I'm going to dive into first kind of the high level reason that underpins all of it, and then I'll talk a little bit more about kind of the concrete aspects. So to begin with, I like to frame the talk around this diagram because I think it helps kind of put you in the mindset of where we're coming from. So this is intended to be like a Dungeons and Dragons alignment grid. If any of you have ever played Dungeons and Dragons, the idea here is that it's a 3x3 grid, and from left to right, we have lawful to neutral to chaotic, and from top to bottom, we have good to neutral to evil. And each of those squares in the grid is representing kind of a personality or a way you approach the world. So in Dungeons and Dragons, they use this to essentially say, well, if you interact with this character, this is kind of the types of behaviors you can expect to experience. Like a lawful good character is going to try to follow the rules and they're going to be altruistic, whereas a chaotic evil character is, you don't know what they're going to do and they're probably going to try to stab you in the back. So it's a good way of, it's a nice kind of concrete but simple way of broadly characterizing behaviors. Why this is useful here is if you think about what agents are going forward, they're essentially new, sort of digital employees that we're wanting to hire into our companies and have work on our private data and collaborate with the rest of the human employees that we already have. And so to begin with, think about how what process do we go through in order to hire human employees? We go through a relatively lengthy process that involves a bunch of things. You start out, there's the matter of establishing a resume, kind of having the right background to show up and be able to even qualify for a job. Then beyond that, there's usually a relatively lengthy interview process. You're going to talk to a recruiter, then you're going to talk to various employees and managers. There's lots goes into kind of vetting that this person has the domain knowledge, that they have culture fit, that they operate in a way that works well with other people. And then there's these other aspects that, like, you're a human being living in civilized society and you're not in jail that say things about whether you tend to follow rules or not. So you go through all of this work, and the goal is ideally you're probably kind of wanting to hire like everyone in kind of that lawful good section. And the reality with humans is that nothing's ever quite so black and white. And in general, I think human employees that we hire into our modern enterprises land somewhere in this upper left quadrant. You've got kind of lawful good down to true neutral. Anywhere in there, people like that can kind of exist effectively within modern companies. And if you look at various tech companies, they probably end up with a lot of chaotic good folks as well. And those companies are kind of able to roll with it. If we now shift back to thinking about agents and where they fit in the picture, it's a little bit different because with agents today, by and large, they fall pretty squarely in this chaotic column. the model companies are doing their best with alignments and guardrails and all this stuff they put into building these models to try to push them up into that lawful good corner. But the reality is the best you get these days is chaotic good, and that's not always the case. And so this really is the crux of the problem with agents, is you've got these superhuman digital workers who you're wanting to plug directly into your private networks, work on your private data. And from a kind of a personality perspective, there's somebody you would never hire as a human, right? And so we can't treat them like humans and just give them a little briefing on what you're supposed to do, and then give them direct access to the systems. We need to do more. That really is sort of the foundation for the challenge of bringing AI agents into the modern enterprise. So from there, we can kind of talk about more concrete pieces of how do we do that then? How do we enable bringing these highly chaotic, highly capable, superhuman intelligences into our business as digital workers? And I would argue that effective enterprise AI requires a number of non-trivial moving pieces. Any AI interaction that is useful is going to require interacting with various data sources and systems within the enterprise. So you need to be building up context for them and maintaining it over time for them to interact with. Maybe this is like a vector database. Maybe this is just general systems within your company. Many things that this could be, but you're building up this context. You're maintaining it so that agents can access it and interact with it. Once you've built that context, they need to be able to query it. They need to be able to reach out and say, well, I've been asked to do a task. I know I have these tools available to me. I need to be able to reach out and ask for this portion of data. Like I need to look into the sales database and find all the sales for this product over the last week. Or I need to look up HR data for this employee that I'm acting on behalf of. Beyond context, you get into things like auth. You need identity. You need to know which agent is doing what work. If they're doing it on behalf of a human, which human are they doing that on behalf of? And which instance of an agent is this? Because it's relatively trivial to clone agents, and it's really important that when an instance of an agent has been tasked to do something, that instance is the one that does it, and not some other clone, or that instance is the one that has the permissions that have been given to it. It doesn't get replicated, and these other rogue agents can go off and kind of access data, which leads us into the next point of governance. Beyond identity, you need to govern their accesses to systems. You want to scope the amount of data they can read. You want to scope the changes and the rights to data that they can make, or the actions within systems that they can take, as narrowly as possible. Next up, there's auditing. You think about AI agents versus kind of classic systems that we've built, business process systems that we've built in the past. Those classic systems, if something went wrong, you go and debug it. You look and see, well, which if statement made us do this wrong behavior. With agents and LLMs, you can't do that, right? You have to, you can't reach in and say, well, where was the mistake in the code? They're really this opaque entity. The best you can do is record everything that goes in and everything that goes out, and kind of flight recorder style, analyze that post facto and see what was it that led to either this bad outcome or this good outcome, or whatever it is you're trying to deduce. Related to that, as you're developing new agents, you want to make sure that you feel confident they're going to be able to do the task that you want from them. In some sense, this is almost akin to interviewing, but with agents, you can approach it differently. You can say, we know there's a task that we have here for this agent. We've got 50 different data sets, kind of example data sets of like, when this thing happens, the agent should do this thing. You can actually replay those data sets through these new agents and validate what comes out on the other side, verify this new agent behaves the way we want, or do A/B testing and say, this new agent is materially better than the old agent. We need to upgrade. And then lastly, when you think about deploying agents broadly in an enterprise, there's a few different pieces that kind of revolve around moving data between them, connecting them. Routing is a big one. Lots of times you aren't going to have an agent living in isolation. The agent is really going to be interacting with other systems within the enterprise, and so you need effective ways for connecting them and routing data between them. I'll give an example later related to fraud detection. You also frequently are going to find that you're going to want to build multi-agent systems. A single agent is great. Oftentimes, multiple agents is better. And again, you need some sort of coordination, some sort of communication between them. This isn't an exhaustive list of things that you need, but this is a pretty good starting point for like the pieces that go into building out effective enterprise AI. And so what kind of struck me as I've been working on AI at Redpanda and learning about the space, wrapping my head around what customers need and kind of the things that are holding them back from being able to deploy these agents that they can build today, but that they can't roll out safely. The thing that's really struck me is that most of these are actually data streaming problems. A lot of them are just literally data streaming problems. And then there's some, like governance, which you might not think of as like a data streaming problem. Like you don't need streaming to solve it, but it actually turns out that streaming is a really good way to solve it in the context of agents. And so for the rest of this section of the talk, what I'm going to do is I'm going to kind of walk through each of these and give a little more detail of what am I talking about here and why is streaming actually a really good way to solve these problems. And then after that, I'm going to talk a little bit about the stuff that hasn't been included here. How do you build that out as well? Because as I said earlier, it's not all about streaming. So to start with, context building and maintenance. So the use cases I'm talking about here are, as I alluded to previously, you have raw data sources, you have SaaS systems. You want to get this data into some form that it's useful for the agents from a context perspective. Maybe this is pulling in data from some sort of outside system, sourcing it, chunking it, embedding it, putting it into a vector database. Maybe this is we want to have an agent be able to run analytical queries against a transactional data set, but we don't want to knock our OLTP database over. Nothing different there between the way that we treat analytics from humans. But again, you've got to take data from an OLTP database, CDC it, possibly transform it, kind of prepare it, and then put it into an OLAP database where it can be analytically queried. These types of use cases, they're classic streaming ETL use cases. I don't think anybody is surprised that streaming is actually a really good way to solve this stuff, especially when you want to build these systems out in a way that they can be maintained over time and kept up to date, particularly with low latency and sort of allowing you to get a real-time picture of the world. One other aspect I would call out is that multimodal here is key. Like you've got all sorts of different types of data. Sometimes it's unstructured data that's coming in. Usually you're taking unstructured data and adding some amount of structure to it, whether it be extracting pieces that you use for metadata or for summarization, or whether it be literally taking everything that's in the unstructured data, pulling it out and putting it into a structured form and throwing away the unstructured data completely. There's usually some amount of extracting structure that goes into it. So this spans across all those different types of data. So this one is not particularly surprising, as I said. The next one I think is governance doesn't need to be a streaming problem. But again, if you're thinking about the scenario of AI agents within a modern enterprise being broadly deployed, the aspect that makes streaming relevant here is you're going to end up with agents all over your enterprise. Any one given agent is likely only to access a few different types of data sources. There's both security reasons for this as well as sort of agent efficacy reasons. Like agents don't do well when you give them 2,000 different tools to work with. They do better with a focused task and a focused set of tools. But if you think in aggregate, you really want to get to a place where you've got a large workforce of agents, dozens, hundreds, maybe thousands of agents who in aggregate are touching every bit of private data within your enterprise. That's just the only way to make them useful across everything you do. And so in that world where you think, a modern enterprise, a small company probably has dozens of systems that you want to touch. You look at the really, really large companies in the world, the JP Morgan Chases and just kind of the largest companies in the world, you're talking literally thousands of different systems that are needing to be interconnected. If you want to approach governance of agents, you have two ways you can do it at that point. One is you can say, okay, well, we've got our 20,000 different systems. We're going to enforce governance at each one of those individually. And you can do that. And at the end of the day, some amount of enforcement is going to be happening at each of those. But if you want to uniformly apply policies across all of your agents, policy consistency across all of these systems is really a big challenge. But if you're using a streaming system to act as the interconnect between all of those data sources, be the sort of messaging path through which agents pull data, send data out, and communicate, such a system like that, such as Redpanda, becomes a natural place to enforce uniform governance of these agents across this technological sprawl. And so this was sort of the epiphany that kind of came to me as I was looking through this with folks, and folks were highlighting it for me. It was like, streaming isn't naturally, the thing you would think of for governance, but in this context of deploying agents broadly, enabling them to pull and push data throughout the entire enterprise with all of this technological sprawl, it actually becomes the most natural place to do it. Next up, moving into auditing. Again, this one feels a little bit more obvious in the streaming space. As I kind of highlighted before, LLMs are opaque. You can't introspect their internal logic. So if you want to make sense of their actions, you have to analyze all of the inputs and all of the outputs. What's interesting and what's relevant here is that when you're talking about auditing for agents, it's kind of a shift from how we've historically done auditing for humans. For humans, we tend to focus on metadata. We say, user X accessed table B, and they touched, this column or whatever. You're kind of at a high level, relatively coarse-grained, capturing, when someone poked into one data source or whatnot, and the time it happened. You're not recording all of the data that they touched. But for debugging agents, because you can't go in and check out the if statements, check out the for loops, what's broken, you really want to actually log and audit all of the data. You want to have a full record of what did this agent do, what did it ask for, what did it get back, what did it say we were going to do as a result, because it's the only way for you to, after the fact, go and piece together the story of how it behaved. And so the fact that you're moving from auditing metadata to auditing data really ups the ante as far as the requirements needed of the system doing the auditing. And this is where a streaming system like Redpanda is sort of an obvious natural fit, because it supports high throughput, low latency, scalable logging of a ton of data getting dumped into it, and then allowing you to access that after the fact. Very relatedly, you can see the diagram basically didn't change here, other than we replaced the audit logs with replay logs. Replay and validation is essentially akin to auditing. It's sort of the other side of it. So validating agent behavior is a classic streaming replay scenario. Audit logs are essentially doing double duty here. You record all of the inputs, run them through the system, record the outputs, and then you assess against some golden output or some expectations of what should have happened. Was it successful or not? And this is really important, both from a development time perspective, because you want to say, well, how is this agent behaving? Do we feel like it's going to do its job effectively? But it actually turns out it's also really important kind of throughout the lifetime of agents, because they are, in effect, very non-deterministic sorts of systems, right? They're building up some amount of context over time. Things are shifting. And so an agent that you've validated works really well one day may drift over time. And being able to run validation kind of continuously as you go along, maybe not in as much depth as you do during the development time, but just to kind of essentially do performance management of these agents, sort of see how they're performing and making sure they're still doing their job effectively becomes important. And again, a streaming system like Redpanda, super valuable for this because it's a very data intensive sort of process of recording inputs, replaying inputs, recording outputs, validating them, things like that. Lastly, we're going to get into the two final use cases, which kind of revolve around kind of routing sorts of things. Firstly, I want to talk about routing in general. One of the things that we've run into as we've talked with customers and kind of been building out some of these agentic systems ourselves is that LLMs are amazing in what they can do, but the reality, particularly today, is that they are not a fit for every problem. They're very expensive compared to other types of systems like human-coded heuristics or even ML models. They oftentimes are a lot slower. And you may not also want to provide them unfettered access to certain data that you're otherwise okay sending through an ML model or something like that. But a good example of where routing comes into play is like with fraud detection. Companies have been investing very heavily in fairly sophisticated ML-based fraud detection systems over the years, and they do pretty well. But they tune those systems such that you want to kind of hit the sweet spot of like you don't really you don't want to let through too many false, which ones is it, false positives. You don't want to reject too many false negatives. But what an LLM or a fraud detection agent can allow you to do is you can say, okay, this is a pretty good system. Let's see if we can level it up. And so what you might do in that case is say, well, we're okay having a few more. Let's dial the fraud detection model such that it has a few more false negatives. So we're going to let a little bit less data through. We're going to have more that we're kind of holding back, that we're saying, some of these are actually going to be okay. We should have let them through. But it's not a huge amount. We're going to send that much smaller amount then to this more sophisticated fraud detection agent that we've built. And we'll let that more intelligent agent do its thing and say, analyze this and figure out, do you think this is fraud or not? It can, for that, you can invest the additional time and energy and money to try to do a better job. And then, because this is just a small subset of those cases, then split that up now into ones that the fraud detection agent says allow that or deny that. Ultimately end up with a better result, but you're not trying to send 20 gigabytes a second of data through LLMs that are burning up your GPU budget in an hour. The other aspect I want to call out related to routing is multi-agent coordination. So when you're building out these agentic systems, it's often useful to have multiple agents coordinating in some way. A good example, again, related to validation. We've spoken with a company who they're building an app that allows an agent to do things kind of within like a sort of a hospital scenario. Kind of bureaucratic, check the boxes or validate things, those kinds of things that nurses or other folks have to, spend a bunch of time on usually, allows an agent to try to do that sort of a thing. But there's two things that they have to safeguard against. One is they have to safeguard against kind of poison pill prompts or things that can come into the agent and either bypass the guardrails that are built into it or basically just kind of make it not function properly. The other is that they also just want to make sure that whatever the agent is doing looks believable. And so what they've done is they actually have built out a multi-agent validation scheme where they have a decision. They have an agent who's kind of making a decision about what to do, and it creates a proposal. That proposal then gets sent to multiple validator agents, each running on a different model from a different model provider. Each of those validation agents makes a determination of, does this look like it's a good idea? Do I give a thumbs up? And then only if all three of them give a thumbs up do they allow it to pass through. or you could decide I want 2 out of 3, or something like that. But you're essentially saying, in general, like these poison pill things tend to be pretty model specific. So if you've got 3 different models from 3 different providers, it's unlikely that you're going to get one that's going to knock all 3 of them out. And you're also going to get slightly different reasonings from them. So if all 3 of them look at it and they say, this looks believable, you can feel pretty confident that you're going to get a good result. And what they found was they went from, I forget the specific numbers, but they went from something like, 60% success or 70% success rate, like up to basically just right at 100, because it was going through this very thorough vetting process. And then all of that then goes down, either gets applied directly or goes to a final agent that is, making the decisions and applying it. All of this is to kind of give you context for seeing when you want to do something like this and build it out at scale, all of the classic streaming benefits that you get from a streaming system like Redpanda, decoupling, durability, fan in, fan out, start to come into play. And they're a natural piece of helping productionize these large-scale agent-based systems. All of that said, I do want to reiterate, streaming isn't everything. You need authorization and identity. You need a multimodal catalog of contextual data to build your governance around. You need querying. If you're building workflows, you may need durable execution, et cetera. So we're definitely not here to pitch you that streaming is the end all to be all, and streaming for agents is the way to go, because that's an insufficient story. But what I do want to do is then acknowledge that we believe there's more to it, and give you a little bit of insight into what more we're doing to expand Redpanda to include streaming, but build out more pieces that allow us to incorporate all the things that we need into the agentic data plane. The first one I would like to talk about is an acquisition that we recently completed. We have acquired a company called Oxa, and they have built a high-performance distributed SQL engine. And we are going to be using this as the basis for a bunch of different capabilities within the agentic data plane. I will talk about some of the things that we're going to be using it for in a little more detail down the line. But first, I would like to bring out Adam, who is the founder and a principal software engineer here at Redpanda now, to discuss, kind of give an overview of what makes Oxa special, and help you understand why we're so excited about having it as part of the Redpanda family. So Adam, please take it away.
Thanks, Tyler. So my name is Adam Szymański. I am principal software engineer in Redpanda, working on query engine. So what we are working on is a technology that allows running your old boring SQL query engines, but with much better performance on a large data sets, like hundreds of terabytes of data within the single query, but with tremendous performance. Why running like the regular SQL is much more efficient than other solutions, and why is that? So to understand that, we need to move a little back in time, like 10 years ago, when most of the currently popular technologies like Spark, ClickHouse, Snowflake were being developed. At that time, typical CPU had several cores, and this has grown right now up to, within the single CPU, right now we can have over 100 cores. But what was not able to keep up with this growth was memory bandwidth. So memory bandwidth nowadays is over 3 times lower per instruction than in the past. So that means that while in the past, to make your program running faster, you had to minimize this amount of CPU instruction being executed, nowadays you need to minimize amount of cache misses during loading data from your main memory. So that was our main assumption while we work on our query engine. We started with the assumption that, okay, the slowest part is, as in the past, storage and network, which nowadays, since we have distributed storage like S3, GCS, Azure Blob Storage, is the slowest part, the most scarce resource when we run our query. The second most important resource is memory bandwidth, and then we have computing. This is true if we are using vectorized query engine, but those, as you know, are commodity nowadays. So if we are using vectorized query engine, the compute is less important than memory bandwidth. The result, I think, is pretty interesting. So as you can see on this comparison of Oxla running star schema benchmark scale 100 and other competing solutions, Oxla can be dollar-wise even 10 times more efficient than the other solutions on the market. And that's it. Over to you, Tyler. See you.
Thanks a lot, Adam. That was great. Really great having you and the team join us, and really looking forward to everything we can do with Oxla down the line. So now, to wrap this talk up, I'm going to spend a little bit of time discussing where we're going with our roadmap, as well as giving a little bit of visibility into the timelines we're thinking about. So when discussing the roadmap, the way I like to frame it is in the context of thinking about the agentic data plane being at the intersection of the three core pillars of effective modern agentic AI. Those three pillars are data, AI, and governance. And so with that in mind, I'm going to step through each of those pillars, talk about kind of the features and the capabilities we're bringing in those. And then at the end, I'll cover the timeline of kind of the combination of all of those together. So to start with, let's start with data. Data is kind of the space where Redpanda has existed for all of its lifetime. And so we've got quite a lot here. I'm sure most of you are very familiar with the things that we do, so I'm not going to spend a ton of time going into detail, but I'm going to kind of call out the high-level pieces, which are, A, to start off with, you need to provide broad connectivity. You need to connect agents to data and systems in both directions, reading and writing, throughout your enterprise. And we deliver that today with Redpanda Connect. You need durable, real-time messaging, which we provide today with Redpanda Streaming, our kind of classic Redpanda product, which is used worldwide in businesses today for many, many mission-critical workloads. Both of these, of course, continue to be relevant for data streaming needs going down to the line. They're still available and are going to continue to be available. But what we're doing now is we're using those as a foundation for building out more of the agentic data plane. The third piece on the data side is the querying aspect. You just heard from Adam talking about the amazing system they've built in Oxla, and we're really excited to bring that to the Redpanda family and utilize it in a bunch of different ways. We're going to show today how you can use Oxla to query data from Kafka topics. This opens up a whole bunch of use cases of real-time querying of data, but when you have a system that allows you to query both Kafka and, say, Iceberg, or Kafka and, say, any other system that you can connect to via Connect, you end up in this world of being able to run federated queries and do analysis across multiple data sources, and utilize that then with agents to provide them with context, but summarized context, because there's many instances where they need to look at very large data sets, but you can't reasonably fit those large data sets in the little context windows that LLMs have. And so this is why having a robust SQL query engine is really important for us as part of the data plane. And we're going to be investing very heavily in building out more features around that. For each of these sections, I want to kind of wrap up by highlighting our focus on interoperability. This is a big part of our product values of being interoperable. And in the data space, it means leaning on open and or de facto standards like SQL, Apache Iceberg, Apache Kafka, et cetera. Utilizing those so that we can meet customers where they are, but also have them not feel locked in. We want to bring the data plane everywhere, but also make it so that you don't feel like you're locked in any space of kind of getting your data into a walled garden and being stuck there. Next up, AI. So AI, we're more new to the AI space, but we have been working on AI for about the last year. And what we're building out in this space is agent support, both hosted and external. So it's valuable to be able to host agents within Redpanda. The hosted agents we can always do a little bit more from a governance and management perspective. At the same time, we are under no illusions whatsoever that we're going to build the end-all to be-all agent development framework. There's hundreds of startups out there many of which are going to fail, quite frankly, but some handful of them are going to create really amazing frameworks, and companies that we're going to want to interface with on the agentic data plane are going to want to use those frameworks. And so a big part of our approach is to say, we're going to build a system that you can host agents with us, or you can bring your own agents that you've got some platform or you've got some way that you've hosted them. You can connect them to the ADP and still have them be governed in the same way. Same thing applies to MCP servers. We have our own remote MCP server that allows you to build lightweight custom MCP servers, so you can provide focused agent-specific context to a given agent. That's built into Redpanda Connect. So anything that you can connect Redpanda Connect to, you can easily expose as an MCP server. But everybody and their brother has an MCP server these days, and you're not always going to want to have to host them, or it's not even going to always be practical to host it within the Redpanda MCP server. If you still need to make use of those external third-party MCP servers, we're going to provide ways to tie those into the ADP as well, so that you can, again, get the same level of governance in that conversation between the agent and the MCP servers to allow you to do auditing and redaction and things like that. Beyond agents and MCP, we're bringing turnkey knowledge-based support. We're going to be rolling out an AI gateway in support of a bunch of the governance features that we have coming. And further down the road, we may look at doing things around agentic memory, vector DBs, and things like that. From an interoperability perspective on AI, again, we're leaning very heavily on open and/or de facto standards. So as of right now, for us, the most important ones are MCP, Model Context Protocol for tools, and A2A, agent to agent, for the agent communication path. Who knows, 6 months from now, nobody may be using those and there may be something else. The AI space moves super fast. We're going to go sort of wherever everyone else goes, wherever you find standards that are seeing broad adoption and bringing material value to customers, we'll go there, because it's important for us that the ADP shows up where you need it and meets you where you are. Lastly, governance. Governance is the piece that we're sort of investing in more upfront. We have more to build out, but I do like to call out that the key foundational piece to having effective governance for sovereign AI is BYOC deployment, which is A, a thing that is really hard to do, and B, something that we already have. BYOC allows you as the customer to deploy really complex, powerful systems into your private networks, so they can act on your private data, but never have that data have to leave your private networks, and you not have to do anything to manage them. It's basically a managed service running in your private network for you. This is super valuable, really hard to do well, and we have one of the most sophisticated and robust implementations of it here at Redpanda. So all of our governance stuff kind of builds on top of that, as well as the foundations of all the data pieces that I talked about. So if you look at everything else in the list here, audit logs, observability, filtering redaction, lineage, maybe I'll leave auth in and auth z out because they're a little more outside of this, but everything excluding the auth aspects, that's stuff that you can build today using the building blocks that we have. So what we're really doing as far as building out governance is building out opinionated first-party features and integrations that just makes this stuff sort of happen automatically or be really easy to do, so you don't have to build it out manually. Audit logs. You create a remote MCP server in the ADP, you automatically get audit logs. You automatically get observability. We have simple, easy ways for you to say, I want to create an MCP server, but I want to filter out credit card numbers so that my agent can never see the credit card number that's in the raw table. It only sees a hash or something like that. These are the kinds of integrations that we're building out, but the bulk of the work actually already exists within the data platform that we already have. It's just being integrated in a more user-friendly way in the ADP. And of course, on the identity and authorization side, we have work to do there. But that also leans into wrapping up and talking about interoperability. Our goal here is to really, as always, lean on open standards, OIDC, OAuth, et cetera, as much as we can. Lastly, talking about timelines. I'm only going to kind of go into this at a very near-term level. I'm not going to try to lay out our long-term roadmap. But we do want to talk about when are we delivering something that folks can actively use. And our goal is that by the end of the year, end of 2025, we deliver what we're calling package 1 of the ADP. And that's going to include basic functionality for MCP, agents, the AI gateway, turnkey knowledge bases, auditing support, SQL, all wrapped up and delivered in BYOC. Then beyond that, of course, more governance features, more connectivity, more queryability, all of that's going to be rolling out as fast as we can incrementally in 2026. And that's it. So thank you for attending my talk. To recap, we started out and I spent a bunch of time kind of discussing how streaming forms a solid foundation for the agentic data plane and effectively deploying agentic AI in the modern enterprise, but also highlighted how it's a necessary but insufficient sort of solution to the problem. Streaming isn't the only thing you need. And I have called out a few of the things afterwards that we need and how we've added Oxla to the story to add to the queryability aspect of things. Talked through the roadmap and timeline and talked about how we're delivering additional governance features on top of it. And then kind of wrapped up here, giving you a little bit of a view of when this stuff is starting to land. So thank you. Appreciate you all coming, and I hope you enjoyed the talk.